For this video, we're going to walk through how to use Excel to conduct a linear regression and also produce a scatter plot. For this video, we're going to use the example here of testing or seeing how well ninth grade standardized tests predict SAT scores for students. First thing to do is go up to the Data top tab, Data Analysis, and then you'll see here on the list of tools, Regression, and hit OK. The first input here is the Y range. This is our dependent variable, or what we're trying to predict. And in this case, we want to predict what SAT scores, or how well SAT scores are predicted. So I'm going to highlight that column. And then for the X range, this is our independent variable. And we're going to highlight the ninth grade standardized tests. If you recall, I did highlight the names of these columns. So I'm selecting labels. At this point in the course, we don't need to worry about the confidence level or the constant is 0. For the output range, again, this is where we want the data to be placed. If you want this on a new workbook or a new worksheet, you can select one of these. But for the purposes of this video, we're going to put the output range right here on this same sheet. And down below, you'll see residuals, a couple options here. For this video, we're going to select just for now line fist plots and hit OK. And you'll notice here it produced two main items to pay attention to. First is the scatter plot. I'm going to select the scatter plot, move it out of the way here so that we can manipulate it a little bit. The first thing you might want to do here on the scatter plot is to get acclimated with the different types of tools and features available. For example, right now it's pretty difficult to see here because all of the data is kind of crunched together between 600 and 850 as far as the standardized test scores. So I'm going to change the scale here to reflect what's normal for these tests. I used an example here, for example, of New Jersey Park scores. And Park scores range from 650 to 850. So there's really no need to have anything below 600 here on the axis. So I'm going to change the bounds here, the minimum to be 650. And I'm going to change the maximum to 850. And then I'm going to do the same thing here with the vertical axis of SAT scores. And SAT scores tend to range from 200 to 800. So now my scatter plot is a little bit easier to see. You'll notice here that there are two different types of plots. The blue data points or plots here are the actual scores selected from these two tables over here, these two columns. The orange is, if you recall, I selected the one checkpoint for predicted points or predicted plots. And the orange here are the data points on a line of best fit based on this regression. One thing we might want to add here is a line of best fit itself. So I'm going to right-click on one of these points, one of the blue points, or the actual data points. And it's going to ask you here to add trend line. So I'm going to add the trend line. For the purposes of this course, right now we're dealing with linear regression. So I'm selecting linear. If you felt like you had information that had an exponential growth to it, you can select that instead. And then if you scroll down, you'll see where it asks you, do you want to display the equation on the chart? And that's what I want to do here. I want to display that line of best fit equation so that we can use it later to make predictions. Also on here, I find that the orange data points tend to be a distractor, so I want to get rid of those orange data points here that are part of the predicted SAT scores. I want to make sure that I left click and select all those data points and hit delete. If I select one of those orange data points there, I'll go through that again real quick. You'll see that I had to make sure to be a little tricky. To show you again, I want to select the orange points there. You have to kind of be a little careful there with that trend line there. To select the orange points, I right click and then hit delete. And that gets rid of those data points that really are the predicted values, not the actual values. And now you can see that I have a nice XY scatter plot here. Just like other tables and charts, you can change the title, for example. I select here. I'm going to say that this is a scatter plot of 9th grade standard test versus SAT scores. So I can change that title however I want. And again, like other charts and tables and graphs, you might want to just spend some time playing around with the capabilities. The other point I want to make out here is the data that was presented here in the summary output. You'll notice that multiple R, or the R value or correlation coefficient, is given there. A couple other data points you want to pay attention to here: the intercept, and it says standard 9th grade. These coefficients here are the values that are part of, you'll see over here, the line of best fit line. So the coefficient for the C standard 9th, 2.23 here, that's my slope value for that line of best fit. And the negative 1155 is my y-intercept, which is if we went back all the way back to 0, that's the value. So, but this formula right here would be used for you to make predictions. So for example, if you had a student, a 9th grader, who scored 700 on their standardized test, you may make the prediction of looking at this line of best fit, eyeball it to be around 400, or you can place 700 into this formula here to produce your prediction. So I hope that helped with both the XY scatter plots and also finding information needed in the regression.